Okay, this is actually for the second day of notes on 3.1. The author combined solving systems of equations graphically with the algebraic methods. So I split them up into 2 days. Okay, so this one we get into the algebra. And you actually did these two methods in Algebra 1, so hopefully this will be some review. I'm going to go back. We talked a little bit about this yesterday, but the methods used to solve systems of equations, and some of these we've covered, some of them you will still get in this chapter, systems of equations. And for right now we're doing 2 equations, 2 unknowns, and then we're going to build on that to 3 equations, 3 unknowns. But the one we did yesterday was graphing. Okay, the one we're going to do today, and you did do it in Algebra 1, was substitution. Another one that you did in algebra was called elimination, and depending on your author, some authors call it the elimination method, some authors call it linear combination. So those are kind of used interchangeably. Okay, and then we will eventually get to another method called matrices. We'll do that in this class. And another method will be Kramer's, what they call Kramer's method. Yep, named after Clay. Yeah, Kramer's method, and that is also what they call determinants. Okay, determinants. Okay, so we're basically today going to go back and review substitution, and we're going to go back and review elimination, and then a couple review problems from yesterday on the graphing. Okay, so if they say solve algebraically, you have your choice. But on some of these, they will say solve by a certain method. So this first one, I'm going to say solve by substitution. First, you have to spell it correctly. Solve by substitution. Okay. And let's say I give you the problem 2x minus y equals 6 and 3x plus 5y equals 22. What I would do is I would look for the coefficients that are 1. Okay? Then you can solve for that variable. Okay, so I'm going to take this equation 2x minus y equals 6 and solve for y. Get y by itself. And you want a positive y. So I could bring the 6 over, subtract 6, and add y. Now, are you at that stage where you can follow that, or do I need to show that? Can you follow that I'm subtracting 6 and adding y? Okay. Okay, so now y is equal to that quantity. Probably a good idea to put parentheses around it. We solve for it in the first equation. So now we're going to substitute that in every place we see a y in the second equation. So now we're going to substitute that in to the second equation. So we'd have 3x plus 5. The critical part is those parentheses or brackets. You can use brackets too. 3x plus 5 times the quantity 2x minus 6 equals 22. Okay, are we good so far? Okay, distributive property. So, and we're now down to one equation with just one variable. So 3x plus 10x, distribute the 5 minus 30 equals 22. Combine like terms. So you'd have 13x minus 30 equals 22. Add 30 to both sides. And I do want to see your steps on this part. 13x equals 52, and then divide by 13, and x equals 4. Okay, for your greater, highlight it, double underline it, circle it, something. Okay, that is the x. Now, then you have it so that you should be able to just substitute right back in. So 2 times 4 minus 6 equals y. So 8, and this still checks your order of operations. 8 minus 6 equals y, so 2 equals y. Circle it, highlight it, double underline it, something. Okay, so your ordered pair is 4, 2. It's always, no matter what letters they're using. If they're using x, y, okay, it's always alphabetical. If they change and they're using A, B, go alphabetical. And the critical part is that you check it, okay? At least do a mental check, okay? Even if you just check, say, okay, 2 times, I'm going to sub back in, 2 times 4 minus 2 equals 6, 8 minus 2 equals 6, yeah, that checks. 3 times 4 plus 5 times 2 equals 22, 12 plus 10 equals 22, yeah, that checks. Okay, so there should be no reason to miss these. You should know before you hand it in whether or not you've got the right answer. Okay, it should check. At least do a mental check, even if you don't write it all down. Okay, so that is substitution. The critical part about substitution is this part right here. You look for any, and you can solve for any of them, but you look for one that has a coefficient of 1, okay, and solve for it, and then substitute that into the other one. Okay, so that is substitution. Okay, let's do one by elimination. So for example 2, okay, let's do elimination, and they will say solve by elimination, or some authors call it linear combination. And I'm going to use both because you may get a different teacher down the road that uses a different. Okay, so let's say I did 2x minus y equals 6. I'm doing the same problem. And 3x plus 5y equals 22. Now, let's talk about this one a minute. I would look for the easiest route. So I would say the easiest would be to eliminate the y's. What could I multiply on both sides? Multiply on both sides by 5. If I wanted to eliminate the x's, I could multiply 3 by 2 or negative 2. I try to get them so they're opposite and then I add. So on this one, let's do the y's. So multiply, yeah, all we need to do, because it's already a minus sign, we just need to multiply by 5. And notice I use the brackets, okay? I'm kind of critical about how you show your work, so make sure you do it correctly. So if we multiply this out, we would have 10x. Multiply this out, minus 5y. Multiply this side, 30. Just repeat that bottom equation, 3x plus 5y. You want to try and get it so that the coefficients are opposite of each other, so then you just have to add. Okay, so now we're at this where we can just add. So we would have 13x. The y's drop out, and that's what they mean, the elimination method. You're eliminating a variable. Okay, and add. That can't be right. Oh, 20. I was going to say, that can't be copying here. This is 22. Okay. Yeah, that didn't work so good. Okay, divide by 13. Because we got to get the same answer both ways. So x equals 4. Okay, and now you can go back. I would go back into the first equation and substitute it back in. And you could even solve this for y like you did before. So that 8 minus y equals 6. Okay, you could subtract 8, or we could add y. Your choice. Then multiply, divide by negative 1, and your y equals 2. Yeah, they will ask you, yeah, to write it as an ordered pair. Okay, and that's easier for you. Okay. Okay, so those are 2 examples. Basically, you remember those types of methods. Okay, yesterday we went through graphing, and I want to do another one of those. So they just ask you to solve and graph. Okay, but it didn't say solve by graphing. It just says solve and graph. Okay, so first equation, 2x minus 4y equals 3. 3x minus 6y equals 8. First equation is 2x minus 4y equals 3. Second equation is 3x minus 6y equals 8. Now I'm going to pick the method because I want to show you. On this one, I want you to solve by elimination, and we're going to eliminate the x's. So to eliminate the x's, I'm going to multiply that top equation by, or I did it by 3, okay, which you could do it your way also. Okay, so, and the bottom equation by -2. And it's not a bad idea to put that -2 on the, at least over here in parentheses, so you know you're multiplying. Okay, so if you multiply this out, you'd have 6x minus 12y equals 9. Multiply this out, you'd have -6x plus 12y. This one's plus 12y. Right? Right? Check my work. Equals a -16. Okay, now, eliminate the x's. Just add. X's are gone. Y's are gone. Oh, wow. 0 equals a -7. Nope, false. 0 equals a -7. So, if you get a false statement, no solution, but what kind of lines are they? Parallel, right? These are parallel, so it tells you you're going to have, before you ever graph it, you're going to have parallel lines. Okay? Okay? So, if we were to graph this, we would take 2x minus 4y equals 3. I'm going to solve for y. I'm going to do 2x minus 3, add the 4y. I'm going to divide by 4. So I get 1/2 x minus 3/4 equals y. Okay, so it goes through at -3/4. Down here, at -3/4. Slope, go up 1 and to the right 2. Go up 1 and to the right 2. Up 1 to the right 2. Or you can go down 1. Okay, should get a line something like that. Okay, now our other line should have the same slope because it's parallel and a different y-intercept. Okay, so let's do the second line. 3x minus 6y equals 8. I'm going to bring the 8 over to the left, subtract it, and add 6y to the right side. Divide by 6. I still have 1/2 x minus 4/3 equals y. So this one's going to go through at a -1 and 1 1/3. So it's real close. Okay, and the slope is still up 1 and to the right 2, up 1 to the right 2. So you should have a parallel line right close to that other one. Okay, so there's no solution on that one. But I wanted you to see that if you did it by elimination method and you get a false statement, that means you've got parallel lines. There is no solution. Okay? Okay? Oh no! I will have to try to correct that with some purple. We'll do that. How come those red and blue show up so good? I don't know. Okay, are we good on that one? Okay, last example. There you go. Here's some purple. Okay, solve and graph. Notice it did not say solve by graphing. It just said solve it and then graph it. So I'm going to give you two equations. -7x plus 5y equals -3. -7x plus 5y equals -3. 21x minus 15y equals 9. Now look at those two equations.
We're lazy. We're going to have no solution. It's going to be 0 equals
0 equals 0, right? If I wanted to eliminate the x's,
Oh, it is 0 equals
okay, multiplied by 3, right? We're still going to show the work. I want you to see what that's going to look like.
Why are
Plus,
you putting it in parentheses this time instead of brackets?
Yeah.
it can still be brackets.
Oh, okay.
To multiply it?
So
You said you were
Yeah.
picking, so
I thought, yeah, I thought.
No, brackets or parentheses, so as long as you're multiplying it.
Oh,
Oh,
Okay, so this would be negative 21x plus 15y, check my arithmetic, equals negative 9. Right at the bottom equation, 21x minus 15y equals 9. And if you add 0, 0, 0, so you get 0 equals 0. True statement?
yes.
True statement, what kind of lines?
help.
Is that
If one line's a multiple of the other line,
on top of the
Same line.
they are coinciding. You're going to end up graphing the same line, right? They are coinciding lines. And remember, if I said, what's the solution to this? You have to write it out in words. There's no way to describe it. Okay, so you have to write out every point or ordered pair. You can say ordered pair. Every point or ordered pair on the line, and pick either equation. Doesn't matter which one because they're the same. I'm gonna pick the smaller one. Negative 7x plus 5y equals negative 3 is a solution. You cannot get the answer without writing that sentence down. Okay, it's every point. So now you only have to graph one line. Okay, so let's graph a negative 7x plus 5y equals negative 3. So I'm going to bring the 7x over. That'd be positive 7x minus 3. Divide by 5. So y equals 7/5 x minus 3/5. So it's going to go down here at negative 3/5. Plot a point. Okay, we're going to go up 7. So go, and you're just counting kind of in the middle. So you're going to go up 1, 2, 3, 4, 5, 6, 7, and over how much? So 1, 2, 3, 4, 5, 6, 7, and over 1, 4, 5. 5? Ah, gosh darn it. 5? Something about like that. Okay, and let's go back for those that were. Let's go back for those that were gone yesterday. Coinciding lines, consistent or inconsistent? Consistent means there is a solution. So yes, there is a solution. So this one has an spell it right. Hang on. Consistent. Consistent means it has a solution. Dependent or independent?
Dependent.
Dependent. One line lies right on top of the other one. It depends on the other one. So they are dependent. Okay? So if it has a solution, it's called consistent. Okay? What about this one? Consistent or inconsistent? Inconsistent. Parallel lines. The prefix in meaning not consistent. So that means there is not a solution. There's no point in common. Dependent or independent? Independent. Two separate lines. They are independent of each other. They are two separate lines. Okay? So we've gone through substitution, linear combination, a little bit of review of graphing. If you get a false statement, they're parallel, no solution. If you get a true statement, they are coinciding lines, and you have to write out a sentence. Okay? Okay, give you time to work.